Hello, Flat Earth researchers, debaters and debunkers. We are told that the angle at which we observe Polaris above the horizon at any given location north of the equator is said to be proof that we live on a globe Earth. Simply because the further away we get from the North Pole, the lower Polaris appears to be towards the horizon. It's illustrated like this, with observers on the globe looking up at Polaris. I'm just going to quickly go through what's wrong with this view and show how it works perfectly fine on a flat Earth as well. So let's just the way Polaris has been illustrated here is this massive thing above the globe Earth. So we'll just make it a little bit smaller and we'll represent Polaris with this yellow circle here, because Polaris is just a spot in the sky, a speck of light in the sky. So let's just make it smaller. Of course, it's assumed that Polaris is millions and millions of miles away. This is something they have to do for the heliocentric globe Earth model to try and make it all fit. So what we have is someone at the North Pole looking directly up at Polaris at an angle of elevation above that observer's horizon, eye level, of 90 degrees. Okay, so we have this admission here with the globe Earth belief that the horizon is the observer's eye level. It has to be, because you have this horizontal line that's perpendicular to the vertical. Of course, with the globe, it's assumed that the further away you get from the North Pole, then you get this change in the angle at which down occurs towards the center of the alleged spherical Earth. So, for example, at 50 degrees latitude, the observer observes Polaris at 50 degrees above their eye level horizon, as shown here. And so this is how the lines of latitude were determined in the first place, by measuring the angle of altitude above the horizon at which we observe Polaris, and then using nautical miles to represent these points of latitude. So we have 80, 70, 60, 50, 40, 30, 20, 10, going down to 0 degrees latitude at the equator, at which point Polaris is no longer visible. It already has appeared to come down to the horizon, and we're told we can't see it anymore because it's blocked by the curvature of the Earth. So first off, we have this scenario that's never been proven ever, with this idea that down changes in the angle because you have to have down going towards the center of the spherical Earth. And then we have this angle of elevation at 50 degrees latitude being 50 degrees. But we can see here that this line 50 degrees above the horizontal for the observer here goes up here, goes past Polaris, when in fact really it should be a line more like this, a direct line of sight towards Polaris. So we can see that this representation here in the globe is not a true representation of what the direction we should be looking to see Polaris. If Polaris is above the North Pole, then this red line would represent the line of sight that we should be looking at. But we're told it's so far away, and it's all to do with the light traveling in parallel lines that makes us look up this way past Polaris to see it, even though it's supposed to be over there. It's just wrong. It doesn't really work. But it's very interesting that you end up with a line of sight to Polaris that's actually lower, a shallower angle than the angle that's illustrated here. So that's what you get. That's how it's defined, either side of the globe. This is the only way that we are told we can prove we live on a globe. There's never been any measurement of curvature on the surface of the Earth. It's all been based on us seeing Polaris appear to get lower and lower and lower towards the horizon the further away we get from the North Pole. Of course, we know that this happens with perspective. We look along a row of street lamps, and the further away those street lamps get, the lower towards the horizon they appear to be. Yeah, simply because the lamps are usually above our eye level, and the horizon is at our eye level, and the further away we get from the lamps, or the further away those lamps go off into the distance, the lower they appear to be towards our horizon, and that's as far as they'll go. So let's have a look at how this can be represented in a flat Earth model. We've got the lines of the points of latitude here represented on a flat surface. Let me just reduce this size a minute. And I've got Polaris just up here above the North Pole. So we've got 90 degrees latitude, so if you're at 90 degrees, the North Pole, you look directly up at Polaris. So if we just take a protractor, for example, and we make a line, for example, we go to 20 degrees latitude, and we actually draw a line that represents the observations that we can make of Polaris at 20 degrees latitude on the Earth. So we draw a line that is 20 degrees, and we end up with a line like this. So when we put all these lines together like this, we get a curve of perspective. Yeah, the curve is here. It's exactly the same as the curve represented on the surface of a globe Earth between the North Pole and the equator. But of course, remembering that we have this actual line of sight, which would be different. It's kind of like factoring in perspective. So when we do that, knowing that the further away we get from something that's in the sky, the lower it will appear to be in the sky. We get these lines that go lower and lower and lower and lower. So Polaris would be the further away we get towards the equator, the lower and lower and lower Polaris would appear to be. And it gives us this curve, a curve of perspective. And this is why I've always said perspective is the imaginary curve. It's all a matter of interpretation. When we draw lines that represent the observations we make on the Earth, this is what we get. We get a curve of perspective. Instead, it's translated into a curved surface with lines of angles of elevation that don't actually match up to where they should be when illustrated on the globe. This is passed off as because the star is millions of miles away, and so we end up looking at it at these different angles to what it really should be. Yeah, it's very simple. This is wrong in so many ways. It's wrong because physics doesn't work like this. You have to invent physics to have things sticking to a ball in opposite directions. If this is the top, if this guy's on the top, then someone on the bottom you have to have a way for these people to stick to this physically impossible ball. And so of course you get gravity. You also have these angles, these different angles towards the center of a sphere. As a model, it's understood that down becomes different to the original down because down is towards the center of a sphere. And this is why people defending the globe obfuscate the word level, because level is perpendicular to the down, so level becomes here and here and here and here. It changes all the time, when in reality level is like this, horizontal. Yeah, and so any angle of elevation to observe Polaris above the horizon will decrease the further away you get from it. And this is how it's represented. Yeah? It's very simple. It's exactly the same. The geometry of perspective is exactly the same as the geometry used to define the globe. It correlates to the angles and nautical miles. It all works out the same. So it really does come down to a matter of interpretation. How are you going to are you going to create this imaginary physics to have things magically sticking to a ball? Are you going to redefine level in order to do so? Or are you just going to have it flat like this as we see and experience it, with the horizon being at the observer's eye level and our observations of something in the sky appearing to get lower and lower and lower the further away we get from it? This matches what we see in reality. When something in the sky goes off into the distance, it appears to sink towards our horizon, and our horizon is always going to be at eye level when we look straight ahead. So to me, this is a much better representation, a more true representation of reality. It is a much better model based on observations in the sky of the Earth that we live on. Even though we don't know the full dimensions and extent of this Earth, this is a much clearer, practical illustration or model of how perspective is the imaginary curve on a flat Earth. So anyone who wants to deny this relationship, this way that observations of things in the sky can be interpreted in more than one way, is being dogmatic, and they just want to hold on to their globe Earth. But anyone with an ounce of common sense who is able to emotionally detach from this ridiculous globe Earth idea can see it like this as well. Alright? That's it. It's simple. Perspective is the imaginary curve. Thank you very much.